Unit 5A, Lesson 3, Reveal and Explain Properties of Functions. In this lesson, we're going to look at quadratic equations in different forms and be able to identify the features of the graph in that form like we did previously. And we're going to use that information to compare two different functions or use that information to solve application problems. To the first example, compare the quantity in column A with the quantity in column B. So we're looking at the function f of x equals -2 times the quantity of x plus 3 squared minus 5. So this is a quadratic equation in vertex form. The value in column A is the maximum value of f of x. And then the value in column B is f of 3, which simply means we're finding the value of the function when x is 3. So we have to find the value specifically for A and B, and then we can use that information to compare them and answer the question. The quantity in column A is greater, the quantity in column B is greater, the two quantities are equal, or the relationship cannot be determined on the basis of the information supplied. So first we can find the value in column A, which is the maximum value of f of x. I know this is a quadratic equation, so it's going to be a parabola that U-shaped. It's either going to open up or down. This case is going to open down because our A value is negative. So if it opens down, I know the maximum value is going to occur at the vertex. So if it's in vertex form, I can quickly identify the vertex that occurs at -3, -5. So the maximum value is going to be the y value, which is -5. Now we go to column B, which tells us to find f of 3. The value of the function when x is 3. So I simply plug 3 in for my x value. 3 plus 3 is 6. 6 squared is 36. 36 times -2 is -72. -72 minus 5 is -77. So now I'm comparing these two values. Which one is greater? Well, this is where you have to understand negative values. A negative value of -5 is actually greater than -77. So the value in column A is greater than the value in column B. Now to the second example. The French bakery sells more croissants when it reduces its prices. Crazy thought. The profit is modeled by the function y equals -0.2 times the quantity x minus 60 squared plus 150. Where x is the number of croissants sold per day, what is the maximum profit the bakery can make? So there's two different ways you can solve this problem. We can graph this in Desmos, and if we graph this in Desmos, again we can see the graph is opening upside down because our A value is negative. So the maximum value again is going to occur at that vertex. The vertex in this case would be the ordered pair that has an x value of 60 and a y value of 150. So the maximum profit they would make is $150. Or you can just look at this in vertex form, understand that the maximum value occurs at the vertex, identify that vertex, which is 60, 150. Then we look at the y value, which is the maximum value, which would be $150. So their maximum profit for selling those croissants when they reduce that price is going to be $150 if they sell 60 croissants that day.